So 3D printing comes under additive manufacturing process. So what is additive manufacturing process? Is a layer by layer addition of materials to form a final layer or a final substance. So basically in 3D printing, we print a layer by layer of material or deposition of layer of material. Will in the end of the final stage we will find a entire model or a structure. So why we came into the field of construction? So you can see the graph from the from 1950 to 2010. So in the period of these 20 years, so there is a wide fluctuation in the automation field in different domains, whereas in construction field the automation is something, it's below the average level. So we are here to fill this gap in India. So our ultimate aim is to reduce the time and labors. So what we build in Tvasta, so the machine, material, software, and printing strategy. So machine is something which is a make in India product, which is completely make in India product, and these machines are separately designed and manufactured in our own factory. As well as we engineered a special material which is not available in the usual market. As well as this material is a special kind which, when it extrudes from the extruder, it gets solidifies, so that we can achieve a number of layers, something like that. So software. So we have a separate software team in our company. So they are also from IIT Madras. So they design our user-friendly software, which is robust in nature and also which is very reliable. So printing strategy. So we have a separate printing strategy for all the structures what we build. So for example, you take a strategy like we start for you take an house or a building, something like that. So we have a strategy from the foundation to the furnished furniture, something like that in the building or a structure. So that is our printing strategy. So right from the beginning to the end, we will do an end-to-end solution. So what are the advantages of concrete 3D printing? Faster construction. As I told earlier, so the 3D printing technology is one of the emerging technology in the technological field, as well as which is in very fast in nature. So you can, for example, you can build a house or a building within a duration of 1 week or 2 weeks. So what is less waste? So during the construction period, you can compare the conventional traditional method of construction. So you can witness a lot of waste during the construction as well as the post construction process. So we neglect that kind of waste. So it around 99% of the material is used completely, and 1% of material is wasted during the printing process or the manufacturing or model. So negligible labor requirement. So for example, you take 100 square feet of building a structure. So any kind of structure, which means, so for building this kind of structure, you need couple of members to get entire structure can be built. For example, you need an operator and an engineer and a fitter for printing, cleaning, and everything. So you need compared to take a traditional or conventional construction method. Here you can neglect a huge number of human resources. So capability customized. So the main advantage of 3D printing is what you think or what you think in like design, we can print. So whatever in your mind, the 3D printer can print what exactly you think. So the customization in the 3D printing structures or buildings, which is an enormous and which is like unimaginable. So for example, you can see some structures in Google like after the presentation. So these structures can't be imagined as like which can be constructed in traditional or conventional method, where it is very easily constructable in 3D printing. So those are the main advantages of concrete 3D printing. So you can see the MEPs involved in this wall module. So this is a wall module. So this is a 3D printed wall module where you can see a hollow structure kind of thing. So this is for installation purpose, as well as the MVPs are installed post process of the printing. So you can have a question like these MVPs can be installed during the printing process as well as the post printing process. It can be done on the both points. So the design team should design a model or a structure in such a way that it should accommodate a kind of MEPs in a particular place like that. So this is an first structure which we built in 2018. So this is in IIT Madras right now. So this is India's first 3D printed house, which is in IIT Madras as well. So this is around 460 square feet of structure, which is fully functional. So this house is constructed in a duration of 21 days. So completely right from the basement to the furnished, completely functional house. So it took only 21 days to construct this house. So this is right now in function in IIT Madras. So you can visit there. So these are the interiors of the IIT Madras house. Exterior. Yeah. So this is a video of IIT Madras house. So first we will do a CAD design model of a building or structure, whatever. So the first process will be a CAD design. So further the CAD design will be converted into .stl format. So which can be easily printed using a 3D printer, like which will be supported by 3D printers. So first CAD model and then to STL format, and then 3D printer. The STL format will be feeded to the 3D printer. So this is the entire story of us 3D India's first 3D printed house. So this is a kind of offset 3D printing. So this house was constructed during the early stage of COVID lockdown. So this is a kind of doffing unit. So this was constructed for two to three medical hospitals in Chennai, as well as in Kanchipuram district in Tamil Nadu. So this unit is designed in such a way that for it is completely designed for doctors, COVID doctors. So this unit was completed during the COVID, second wave of COVID. So you can see the diagram over on the right top. So entry and exit. So there is a separate entry and separate exit for a structure. So this entire structure was constructed duration of 5 days, and this entire structure was it's complete in a prefab structure. So where the structure is built and the entire structure is moved to a site location and load like installed there. So you can see you can see over in the pic the its installation of these things, like entire structure is placed over there. Can you hear me? Yeah. So you can see this entire structure is placed over on something like a basement. So this structure is completely built over the in a factory, and the structure is transported to the site and installed there. So it took only like 20 to 30 minutes to install the entire structure over there. So this is a completely like a mobile structure kind of thing. So this is the first mobile kind of structure thing we did. So these are some sanitary blocks we did for Indian Air Force. So this is a kind of 1,500 square feet of guest house for Jawans and airmen for Indian Air Force in Gandhinagar. So this structure comes under a seismic zone 4. So our material team designed a material for every geographical localities in such a way that it withstands the climatic conditions and the geographical conditions over there. So this is an facade wall for BPCL Krishnapatnam. So this design is like somewhat inspired from a Rajasthani architectural thing. So you can see in India's first 3D printed bus stop, which is at Godrej facility at Mumbai. So this structure is something different from a usual structure. So you couldn't see any support structure for the curved ceiling over in the bus stop. So this is achieved only by using 3D printing technologies. So these are our upcoming models. So these are some new designs where you can see hollow ceilings and hollow tiles like kind of things. So this is a like fluidic design over an exterior of a building. So this is a G+1 structure. So this is a different kind of thing where you can see some holes over and wall as well as in ceiling. So this holes can be filled using any filler material which you want. So this is a kind of customized structure. So this is an upcoming, like this is the project we are currently working on. So this is an IIT Madras guest house. This is we are building a guest house for IIT Madras. This is a G+1 structure. So you know the most of the IITs in India are inside the forest campus. So this IIT Madras also, like we build this structure in a forest kind of geographical area. So our ultimate aim is to not cut on any trees during the period of construction as well as the post construction process. So our printer will be going through the trees and print entire structure in a one go. So we will be installing an on-site printer over there. So the on-site printer will be have a capability to build an entire structure inside the given area with the cutting down of any trees. So these are some theoretical possibilities of 3D printing. So we are currently working on our multi-story buildings. So these are some G+7 structures and other on-site printing strategies over there. So these are some architecture elements possible by using 3D printing technology. So these are planters, seaters. So you can see planters, seaters, different kind of sign planters, twister planters, timer planters, column beams. So you can see some fluidical design over in the column and a dome kind of structure and a plain dome kind of structure. So these kind of unique designs can be achieved using 3D printing technologies, and it is very easy to achieve these kind of designs. So this is our first facility in Perungudi, so which is in Tamil Nadu. So we started our printer like this, and we evolved to a next stage. We upgraded to a next stage of printers in a day-by-day basis. So this is our first version of production printer. So using this printer only, we constructed India's first 3D printed house. So the modules over there are the India's first 3D printed house modules. So this is a second version of that printer. So you can see the size difference over this. So this is a second version of the concrete 3D printer. So currently this printer has dismantled and we have installed a new next version of this printer. So this is the third version of concrete 3D printer. So this is a kind of gantry type of printer. So we are currently, this is in our Solnur factory, which is in Tamil Nadu, Chennai. Uh, so this is an on-site printer. So like previous printers are off-site printers. So there are different kind of strategies during the printing of modules. So where off-site printers are a strategy where we build modules in our factory and ship those modules to the site and integrate the entire module over to achieve the entire structure. So that is how India's first 3D printer house was built. Where on-site concrete 3D printer is different from off-site, where we install an entire printer over the site and the printer will start printing the entire structure in that site in a single go. So that is how we are working on this India's like IIT Madras guest house, which I showed earlier. So you can see in a couple of men sitting near that nozzle or an extruder. So this is how like this printer is something very big. So that's why for the comparison only we put this picture over here. So this dimension will be around 10 cross 10 meters of length. So this is very huge. So this can build an entire structure of G+1 structure over there. So these are our awards and collaborations in recent times, as well as we have received a number of awards in the during like in the recent times. So this is an recognitions and press things we got in recent times. So India's Prime Minister Sri Narendra Modi ji mentioned in Monkey Path program about 3D printing technology. So Sri Venkaya Naidu visited our India's 3D printed house in a couple of months back. So Nirmala Sitharaman ji inaugurated our house during the COVID period. So this house was inaugurated virtually.
साथियों,
So this is our core team. So they are from IIT Madras as well as from different institutions from India. So any questions, guys? You can go up with Q&A questions.
Yeah, hi Ashwin. We have some questions prepared for you, and
Yeah,
also we will be taking up after that the questions of audience from chat box.
yeah.
So let me share the screen once. I hope the whole screen is visible.
Yeah, yeah. Go ahead, please.
So the first question is like, what was your inspiration behind starting Tvasta in the initial days? How did you guys plan? Like, and what kind of problems did you face in your initial days?
Yeah. So as I told earlier, so our co-founders were working on a projects in there during their graduation process. So they started with the normal 3D printing technology. So then they emerged into an construction field where it needs some automation kind of thing to eliminate labors and promote the technologies in the field of construction. So that's how they got the inspiration in construction 3D printing in India. So before we start, so there are a number of companies in world where they started construction 3D printing before. So from
Yeah.
them, we got some inspiration and we started in India. So we are the first to start in India and we are one of the leading concrete 3D printers manufacturers as well as a concrete 3D printing technology in India. So during the year of 2016, our co-founders, three co-founders and their friends in IIT Madras, so they started on a small club. That small club emerged as an Tvasta, as an incubator in IIT Madras, and then slowly evolved into an Tvasta organization in the year 2018. So in 2018, after the construction, during the construction of the 3D printed house, we emerged as a separate organization. So that's how we start. Hope I answered the question.
Yeah. And would you like to add any any initial the problems that you faced in your initial days?
Sorry?
Would you like to add and describe some problems that you faced in your initial
Sure.
days.
Sure. So, for like what we are now was kind of 6 years of R&D we went through. So 6 years of
Yeah.
R&D was a thing. Like all my material team, my software team, my architect team, my design team, everyone from the start, from the beginning. So they are in R&D phase for past 6 years. So in the duration of the 6 years, we faced lot of problems like material, like the material we engineered is. So, like when I show the video in the live stream, you can understand what I'm trying to say. So you see, like when the material is pumped into an extruder to the hopper, then the hopper will push the material to the extruder. The moment the material extrude from the extruder, it gets solidifies. So that when the addition of layer by layer on the material, it does not any get bulged, or it does not get affected due to the addition of load. So we design that kind of material in that, in a such a way that it withstands load bearing capacity. For example, you can see this wall module in India's first 3 minute house, in IIT Madras. So this wall can withstand about G+2 structure of load over it.
Okay. Sure.
So the one of the problem was material, as well as the next problem was the design. So we need to design and very user friendly kind of thing, well, and very user interfaced kind of software as well. So it should not be very complicated for the normal layman workers. So they should be easy to understand or easy to work with this kind of technology. So they need to adapt this technology very easily. So we face like a couple of problems over there, and somehow we sorted out. And now our software and material and printer, everything is very user friendly and very robust in nature. Yeah.
Yeah. Sure. So let's move to the next question. Uh, so are you guys as we saw in the video, and you explained that you print the models, you print the blocks in your factory, and then move it to the construction site. So are you
Yeah.
guys planning to make portable 3D printing machines, which you will directly bring to the construction site and print the blocks and use it for construction?
Understood.
Yeah.
So right now we have a printer in our factory, so which
Mhm.
is an robotic arm mounted on a crawler, so which is a kind of mobile 3D printer. So as I
Yeah.
said earlier, we have different type of printing strategies like on-site and off-site. I explained briefly during the presentation. So this is a kind of on-site printing where the mobile 3D printer will go to the site and print entire model, entire structure, anything in the site. So it can so that due to the mobile action of the printer, due to the moving action of the printable areas doubled or added like n numbers of like site as based on the site area. So as well as like our on-site 3D printers or like kind of portable 3D printing machines, so which can be transported to different localities, different geographical areas all over in India. So for example, we built a few success in Leh Ladakh, we built some success near Gujarat, so we built success in Tamil Nadu. So in like on Kolkata recently, so we covered almost all part of India. So every kind of geographical locations we covered. So our material, our printers are portable to all kind of geographical locations. Not in future, we are
Okay.
currently working on it, and we done it. We did it. Yeah.
Yeah. Cool. Yeah. So let's move to the next one.
Sure.
So next question is, can this technology of 3D printing be customized to print other objects made of different materials like metals, plastic, or maybe recycle the objects made of metals and plastics to make new ones? Can it be
Yeah.
customized?
Understood. So Tvasta is working on construction 3D printing. So the 3D
Yeah.
printing is a technology where you have a number of materials can be printed. So there are kind of printing strategies. So only the strategies varies for the material, like printing of different materials. For example, for printing of plastics, we use FDM printers, fusion deposition modeling printers. So these kind of printers, so this is a very small scale printers. So this is easily available in the market as well. So it costs around 20-25,000 in Amazon as well. So FDM printers. So you can please print like complex structure using a plastics and PLA material, PIC material. Like there are a number of materials over there. And coming to metals, so there is a kind of a separate printer for printing metals. So that is kind of M3DP, metal 3D printing technology. So we have a separate printing strategy for that. For example, the metal will be sintered using a laser, so that the high powered laser, so the metal will be gets dissolved and get solidified after the get contacts with the laser. So that's how the metal 3D printer works. So coming to polymers, SLS there, selective laser sintering 3D printing technology. So we have a SLS printer over in our factory. So this printer using this printer use polymers to print. So we can this so based on the application, the printing strategies and printing materials will be varying. So Tvasta is working in construction field. So we use cements, mortars for construction of structures. Whereas the metals, plastics are based on like for printing of biological components like heart, organs, tissues. So we use bio printers for that. So there are a number of printing strategies and printing technologies for different materials. Based on the application, it varies. Understood?
Yeah.
Yeah, thank you.
So the next question is like, can you comment on the strength of the houses made by the 3D printer? Is it more stronger than the normal houses built or not?
It's a good question. So yeah, the question is like I said earlier. So the wall module of the wall module of the house can withstand about G plus 2 load kind of structure over there. So this house is something very reliable, and it is very strong strength compared to the conventional mode of constructing the house or structure anything. So comparing like in numbers, for example, for example, I'm saying, so for traditional or conventional method of construction can withstand about 30 to 40 years, means this can about double the amount of the year in numbers, I'm saying.
Okay.
So and as well as we will reduce the number of like we will reduce the duration of the like construction durations.
So
Let me
it takes less time.
yeah, exactly. So that's what like we
And
constructed an entire house in 21 days.
okay, that's great.
Yeah.
So so can we also use like if we I guess you answered that we can use this 3D printing technology in health and medicine sector. So
Exactly.
is it possible?
Exactly,
Yeah.
exactly. So, like what I said is, whatever you think in your mind, we can print. So 3D
Okay.
printer can print any complex
Okay.
design. It can print. So for in bio perspective, in the perspective of medicals, so I said like bio printers are there. So we can print any kind of prosthetics, any kind of organs, tissues, bones. We can print. So only the thing is that the only the strategies of printing is printer will be varying and the material will be varying based on the application. That's what. Yeah.
So adding on to my previous question, are you guys planning to expand your work, your company to in different sectors of 3D printing, or maybe you are planning to expand to different cities of India or maybe different countries in future, or make bigger houses?
Yeah. So we are currently working on our expansion of our organization all over India. So
Yeah.
we have already like you see like India's like bus stop by in Godrej facility. So we have printer in Mumbai and in Kolkata. So we have like somewhat established the printers all over India, as well as like lot of central government organization bought our printers for production purpose. So we are in touch with the organizations, as well as we are in
Hmm.
touch with the government side, so that we can promote our technology in future. So we are currently working on to promote our printers in international level. So we are promoting our technology to world. So we are entering into the global market, and we are competing other countries as well. So we are representing India in a global market and competing with other leading construction 3D printers.
Okay.
Yeah,
Yeah. So let's take some questions from the audience.
sure.
I I hope the screen is visible clearly.
Yes, it's visible, Ayush. Let me check the chat. Why did not put 3D printed bus stop in Madras first? Cost factor. Yeah, so I'll answer the first question. So in Metro, so we have a bus stop in Kottrupuram in Chennai. So, but the first bus stop was printed for Godrej. So since we had a collaboration with them, so we started a project with them as a bus stop, and then we gave a printer for them. So further, we printed a bus stop in Chennai as well, which is in Kottrupuram in Tamil Nadu. And cost factor, so comparing in house kind of structure, so which is very 20% higher than the normal construction, like normal conventional mode of construction. So we are currently, our material team and our design team is currently working to reduce the cost factor, which is very competitive. Maybe in 3 to 4 years we will be quoting a price which is very competitive to the conventional mode of construction and mode of technology. What about the availability of material used and also what's the planning of that? Yeah, so we are not using an usual concrete which is available in the market. So we use a separate grade of concrete where we have a separate collaboration with India Cements. So we get a special grade concrete, and we make an concrete mix in our factory, which is not available. So we add some kind of chemicals over it for getting that strength and getting that kind of solidifying in nature. So and the moment when I say like when we give printer, we are the leading manufacturer of the printers. We as well as give the motors for the printing printers who bought, like the customers, we like what they get the printer. So the material also we are dealing with, where we can, like, it based on the applications, right? So like it varies from locality to locality, geographical location to location. So based on that atmosphere, we will design a material. What are the disadvantages and limitations of 3D printing technology? Is it limited only engineering and fields and applications? It is not limited actually. It can be used in all kind of every domains as well. So the disadvantage is, ideally speaking, the technology is very like we should. The people is not ready to adapt the technology in India. So we need to create awareness for adapting this kind of technology in India. And other disadvantages may be, like we need like the material cost will be for every printing will be higher than the usual cost of the materials for the normal materials in the market. So that maybe that is the advantage. Sure. Is the city printing useful for farmers to build a small rooms in fields to save their? Exactly. So, as I
Yeah.
said, right now our print, like our we are quoting like bit higher than the conventional method of construction. Maybe in 3 to 4 years, we will be giving a competitive quote for comparing to the normal traditional constructors. So it is very useful for not only for farmers, all the middle class mans, like all the peoples in India. So like building a house or building a structure is like a dream for every individual in India, like according to my perspective. So we are here to give that satisfaction to the every individual in India as well as in the world. Yeah.
Also, Ashwin, Hemant has asked one question regarding what about the availability of materials used, and also what's the planning of increasing the demand and construction materials required for printing?
Hemant, let me check. Okay, what about the availability of material used, and also what's the planning of increasing demand and construction? Yeah, so the availability of, like as I said earlier, the availability of material, like it will be like you can get only through some customers, some clients directly from the site of the cement. Like for example, we are partnering with India Cements, so we will be getting that high graded cement from their factory. So this cements, which is not for sale for normal civilian or kind of for the public. So this material, not only the cement, after that we have a special sand, we have a special mixture, we have special chemicals, aggregates, and fibers. So we add these kind of materials together and create a concrete or create a motor, right? So this material is different, and they're increasing the demand. So after passing the years pass on, the technology will be adopted by the every individuals in India. So at that time we will be in demand of materials, like for example in South India you can witness demand in sand, river sand for the in the field of construction, right? So maybe in a couple or 3 to 4 years we will be in a demand of our separate material, construction material.
So, Ashwin, Isha is asking, how are you going to marketize this 3D printing construction? Like, how are you going to increase your reach to general public or maybe other companies?
Yeah, so good question. That's a very good question. So right now we have we have a number of partners and we have a number of collaborators with us. So they are from the global level collaborators. For example, Saint Gobain, Godrej, L&T. So we are currently working with L&T to collaborate with us. And then so we have an Indian government, Indian Urban Housing Affairs, Tamil Nadu Housing Board. So we have a number of government collaborators as well. So we are doing a lot of government projects as well for public. For example, like a community hall in Tamil Nadu, and like an structure which is an 1 BHK structure in Kolkata. And and also we are working to like a kind of structure which is very unique. So this kind of structures can, which is not sponsored, which is very sponsored, also like collaborated with a lot of like huge competitors in India as well as in world market. So they are helping us to promote our technology in global market as well as in Indian market. And these collaborators will help us to promote our structures to the peoples, and they will be act as a mediators, they will be act as a mediators from the technology and the buyers, like the public.
Yeah.
Yeah.
So, there's a question by Ria that how is the 3D printing technology useful for Indian Army? And adding to that question also,
Yeah.
Keshav has asked, is this 3D printing technology can be used for agriculture purposes also?
Yeah, I hope I answered the question for agriculture purpose. So coming to this Indian Army question, so we, as we seen in the slide, we have a couple of structure which is considered for Indian Air Force. So also we constructed a few structures for BSF, Indian Army. And also we are in a kind of working on a current project where you can shift an entire structure to place. You can carry a structure to place and you can relocate it, kind of thing, like for example a kind of tent, but it is a concrete structure. Understood? So this is for our jawans and soldiers there in border. So we are currently working with Indian Army regarding this kind of project. So yeah, we have like lot of things to do with Indian Army as well. Yeah.
So, adding to my one of the question regarding whether it is the 3D printed houses are stronger than normal houses or not, Akshit is asking, in the disaster situations like earthquake, will these 3D printed house perform better than the normal?
Sorry, come again. Where is the question? I'll
Uh,
see.
yeah, the last question, Akshit is asking
Yeah, in the region of
whether the
yeah,
yeah.
understood.
Hmm.
So as I said earlier, the structure which we built for Jawans in Gandhinagar, Gujarat. So this structure, like two guest houses we built there, which is around 1,500 square feet, 750 square feet each. So this structure comes under seismic zone 4, so which is in a high earthquake prone zone area in India. So like in India, so there are special regions for earthquake prone, like Gujarat, Delhi. So in south you can see, like in Tamil Nadu we built a house right in IIT Madras. So this structure is something that we don't need much strength compared to we built in Gujarat, right? So India, Tamil Nadu is not in a high earthquake prone zone area, so it comes under a seismic zone very low. Where Gujarat comes under seismic zone 4, so we built a specially engineered material to withstand some kind of shakes, and the module can absorb some kind of vibration over there. So it is built in a such a way that it can withstand that kind of earthquake kind of thing or a disaster kind of thing in there in a particular geographical area. I guess you are in mute, Ayush.
Yeah, I guess there are no more questions. So can we start with the live
Yeah,
stream
yeah. Can you
session?
can you
Yeah.
can you give access to my colleague Stevenson? He's in a meeting, so he'll be giving a live
Yeah,
telecast of the printing technology. Yeah.
yeah, sure. Vinayak, please look at it.
Yeah, I guess he got an access, so he'll be showing that live stream now. Yeah, it's visible, Stevenson. Yeah, thank you. So this is what I said. You can see a layer by layer of addition of material over there. So the moment the material extrude from the extruder, it gets solidifies, right? You can see the white color triangular thing is kind of nozzle. So the moment it gets extruded from the nozzle, it gets solidifies. That's why we can achieve a layer by layer of structure. Stevenson, can you hold the phone in the stable position, please? I have there is some network issues, guys. Yeah. Yeah, can you hold the phone for stable for one layer, please, Stevenson? Thank you. I hope you can see, guys. So this is how we work. So this is a kind of gantry kind of printer. So this is an offset printer. We built modules in a factory and ship this module to the site and integrate it over the site to get an entire structure over there. Yeah, thank you, Stevenson. Thank you. Ayush,
Yeah,
yeah, hope you enjoyed the
yeah,
session.
yeah. I hope our audience has enjoyed a lot, and uh, this is the like
Your voice not like, yeah, yeah.
uh, maybe there's just an yeah, yeah. Thank you, Ashwin and team Tvasta for exhibiting, and the
Thank you.
audience for putting putting so much interesting questions for Team Tvasta, and thank you to Team Tvasta for answering too. And the
Thank you.
session ends here.
Thank you. Thank you all.
Yeah. Follow do follow Kshitij on various social media platforms, and the links to our social media platforms are in the chat box. The chat is pinned. You can follow and get updates regarding various events and competitions that will be coming and exhibitions.